This is lesson 6.5, examples 5 and 6. We're going to do these together because they really build on the same concept of the relationship between the angle measures of a triangle and the opposite side lengths from those angle measures, and how those two are directly related and linked to each other during the construction of a triangle. So example 5 is actually going to build from theorem 6.8, known as the triangle longer side theorem, where it states the largest angle in a triangle is found opposite the longest side, and also the smallest angle is found opposite from the smallest side. So the directions here are to order the angles from smallest to largest. The first thing you should notice here is the actual angle measurements are not there. So to save ourselves the time of getting a protractor and actually measuring these angle measures, we're going to use that relationship of the larger angle should be across from the larger side, and the smallest angle should be across from the smallest side. So because 6 is our smallest side right here, put a little s there for small, we're going to see that angle C is actually our smallest. Then we have angle A, since it's across from the 15. And then finally our largest angle is going to be angle B, which happens to be across from the largest side. Pause the video here and try the next two on your own, and then double check your answers. For number 2, again, we're actually going to find the smallest side, which is here as a 6, and that would give us that R then is our smallest angle. It has to be in order to build the smallest side. The 8 is the next length of side we're looking for, and that is across from angle P. And finally, that leaves us with angle Q, which should be across from the largest side length, and it is. So that was an S and that was an L for large. Number 3. Sometimes our eyes can be a good judge like in 1 and 2, but when it gets tricky, your backup plan should be to fall onto these side lengths. With this being our smallest side, that should be across from our smallest angle, angle B. 24 comes next, and that is across from angle C. And finally, that should leave us with angle A, and that is across from the largest side there, the 26. Now example 6 is going to build on that same idea, only now our job is to list the sides in order from shortest to longest. And again, you'll notice the actual side lengths are not there. But using that same concept as before, if we need to go shortest to longest, let's look for the smallest angle. Here is our 50, and that means that this side, built by the letters R and T, remember these are side lengths, and these are actually segments, should be our smallest. Well, then we're going to go across from the 60 next, so that should be an R and an S, or you can call it S and R, it doesn't matter, it's the same line segment. I'm just going in alphabetical order. And finally, our largest angle is 70, so it should build the largest side of the triangle across from it as S to T, or again as T to S. But there are your side lengths listed in order from shortest to longest. Again, pause the video, try 2 and 3 on your own, and then you can check your work. Now in number 2, it would be very helpful if we knew what this angle was right here. It kind of looks like it's the smallest, but our eyes may play tricks on us. So just to double check that, we're going to do just the simple math of 180 degrees in a triangle minus the 110 that's down there at F minus the 37 that's down there at D, and we should end up with 33 degrees in that corner. And therefore that is actually our smallest angle like we thought it was, so our shortest side is segment DF. We can now then do the 37 across from the EF side that it creates, or that it controls in our triangle. And finally, 110 being the largest angle, it should be opposite or controlling the largest side. So we have D to E there as well. So that would be our sides listed from shortest to longest. Lastly, over here in number 3, again, it would be very helpful if we knew what B was to make the best ranking possible. So just to double check our math here, or double check our I's, I'm going to take 180 minus that 90-degree box down there, minus the 40 degrees that is at C, and we'll find out that that's 50 degrees sitting there. So this time around, C is our smallest angle. So it is across from, we're observing the smallest side, the smallest side, B to D. Then we're going to go, the 50 degrees is opposite from side C to D. So that'll be our second side. And finally, our longest side happens to be the one across from the largest angle. That would be side B to C. So there you have it in that case. And that should make sense to us when we see the hypotenuse of our triangles have to be the longest side in the triangle because it's across from the largest possible angle in a right triangle.